Alright, so we're looking at the tangent normal to ellipse in Cartesian form. So the first thing we're going to consider is the tangent. We need to be able to use that implicit differentiation skill to be able to get the gradient of the tangent at any general point P on your ellipse. Alright, so we need to do d dx of all those. Okay, so we differentiate everything with respect to x because that's what we normally do. Right, and when we have the y variable, we need to make a manipulation. So, d dx of x squared over h squared, so there's no y variable here at all. Alright, so it'll be 2x on h squared. Now we've got something we're differentiating with respect to y, so I can still differentiate that, but after I need to write dy dx because I differentiated y with respect to x. Alright, equals the derivative of the constant, which is 0, and now we need to make dy dx subject. Alright, so we have negative 2x over a squared times b squared over 2y. So it's negative b squared x over a squared y. Right, so the point we're using is P there. So at P of x1, y1, dy dx is going to be negative b squared x1 over a squared y1. And that is your gradient of the tangent at any point P on your ellipse. Okay, so now I need the equation of the tangent. So what do I need to do for the equation? Point gradient formula. Okay, so y minus y1 is equal to negative b squared x1 a squared y1. Okay, and in this case, x and x1 and y1 are the actual point. All right. Okay, expand everything out. Right, then I'm going to divide everything by a squared, b squared. That's this maybe somewhere a squared. x1x over a squared. x1x over a squared plus y1 y over b squared. Okay, so let's get that subject. x1x over a squared plus y1y over b squared. So move this to this side equals x1 squared over a squared plus y1 squared over b squared. Alright, so in the formula we've got your left hand side fine, but the right hand side is 1. But on our right hand side we've got x1 squared over a squared plus y1 squared over b squared. Now how are we going to get that equal to 1? What does the thing on the right hand side look like? Of a? Yeah, isn't it? So x squared over a squared plus y squared over b squared, but we've substituted the point in x1 and y1. That must be a point on the ellipse. Therefore, that point, when you substitute in the formula, must equal 1. Okay? Done. Since x1, y1 is on ellipse. Okay. So that is the gradient of the tangent, the equation of the tangent. Right. So now I need the normal now. Right. So we've done most of the work already in terms of setting up the gradient of the tangent. So now we need to set the perpendicular. So that's the tangent. So we need the reciprocal and change of sign. So a squared y1 and b squared x1. Reciprocal and change of sign. And substitute into your point gradient formula. Let's spin, yep. Alright, this time I'm going to divide by the product of the coordinate. Difference, so we've got that, take away that a squared, take away b squared, yep. Alright, so b squared Alright, so move things to the correct side and considering your signs, we have the result. Okay, so if you know the point, and obviously we'll know your values a and b from the equation, alright, you can just simply substitute into those equations and it will come up with your gradient, the equations of the tangents and normal. Okay. Otherwise, we need to go through the process. So you're familiar enough with the process, just the implicit differentiation is the new skill there. you know how to use your point gradient formula, just a bit of manipulation of algebra, etc., and then we'll have the answer. Alright, let's try the, oh, there it was. So there's the equation of the normal. Okay, let's do one question to finish up. Let's hopefully get through the next one. Anyway. Find the equation of the tangent to the normal to the ellipse of x squared plus 4y squared equals 100 at the point P of 6, 4. Right, so that is the ellipse, even though it's not in our normal form that we recognise. So to be able to get it into your normal form, we need the right hand side to equal 1. You need to divide everything by 100, and that will give you the format you need to, if you're going to use the formula. However, I'm going to derive them. So d dx of x squared plus d dx of 4y squared is 100. Oh, sorry. d dx of 100. Right, so 2x plus 8y dy dx is 0. So dy dx is going to be negative 2x over 8y, so it's going to be negative x on 4y. Right, so at the point P, which was 6, 4, derive dx is negative 6 on 4 times 4, which is 16, and negative 3 on 8. Okay, so 8y minus y1, which is 4, equal negative 3x minus 6. Okay, so it's up to you whether you want it in y equals mx plus b form, which probably would be more handy in some areas. Okay, I'm just going to put it in general form. ay take away 32 is negative 3x plus 18. So 3x plus 8y, 32 take away 18. Right, and there's your equation of the tangent to the ellipse. Right, so the perpendicular gradient is 8 on 3. Do reciprocal and change the sign. Alright, and then do the same thing with the new gradient. Okay, so again, general form or y equals mx plus b form. Okay, so I would suggest you would do it this way so you don't have to remember any new formulas. Okay, but that's up to you. If you want to go ahead and remember formulas, go for it. Okay, otherwise we'll just do the maths. So we know how to do the maths once we get this skill. Check done, and then we can go from there. Right, had enough? That's a shame because I've got to do the question to do. It's a lot of fun.